a nice present to Mama, but I don't know what is good. So I will choose a present with sun, and using a flowchart would be helpful. First go to a gift shop nearby and go into the store and choose a gift. When it's hard to make a decision, don't worry, just follow yes or no. Sun, does Momo like robots?
No.
Does Momo like dolls?
Oh, good choice.
When it's hard to make a decision, don't worry, just follow yes or no. Flowchart will help my decision. Dad, what kind of dolls does Momo like? Sun, does Momo like lion dolls?
No.
Does Momo like horse dolls?
Oh, I think so.
When I follow yes or no, I'll get the results that I want to know. Even if we go back and do it over again, flowchart will help my decision.
Can you hear me? Welcome to the National Visual Free Coding class for kids, and this is an avenue for. Sorry. This is an avenue for every kid to participate in a free training where they get acquainted with what coding is all about and have the opportunity to practice something unique about coding. Okay, so please, before we move on, I would just like to give a brief on few things I would like us to cooperate with me on. And that's, first of all, we really appreciate if everyone can mute their mics. You can just use the visual, and when it's time for a question or maybe during the practical section, you'll be allowed to unmute your mic. But for now, I really appreciate if you can just mute your mic. Then if you have any question, please, you can just use the chat box here. You can just use the chat box on your screen. So any question asked will be attended to. Okay, so let's start our class for today. So basically the class is starting now and will be ending by 2, but the first section we like to enlighten everyone on, and we move to the practical section where I know many of you maybe it's most have coding program in the school. So however, you might be familiar with few things I'll be saying, but at the same time I'll still appreciate if you can cooperate with me as we move on this class. Thank you. So first of all, I'd just like to give an introduction on coding. Because everyone says coding, but the truth of it all is that coding is still the same word used for programming. Coding and programming still goes along. But before then, I'll just like us to have a brief history. Sorry, somebody's mic is on. Okay, I just want us to us to have a brief on computer itself. How did coding come about? And it started from somewhere before it got to a point whereby everyone we now need to be trained on how to program. But it all started as back as the days of the farming age, and during this time there was nothing like computer, nothing like electronics, nothing like your laptop. There's nothing like the phones you use. It was just so traditional. And at this point, please, can you see my slide? Okay, so Um, so I was talking about a brief on how computer came about before coding became very important for us as children. So it started as far back as the traditional age where farming was the major aspect of development, and during this time there was nothing like phones, nothing like your computer, there's nothing like your laptop, there's nothing like internet. But at this particular time, you know the, this era, they still needed to count, assuming they want to count the cattle, they want to count the plantation, and they make use of what we call stone. So at this point it was known as the Stone Age. It was known as the Stone Age. But at the same, as time goes on, invention begin to take place. It's moved from the Stone Age, and there's something from this Stone Age that we still use up to now, which we know as the abacus. I know everyone uses it in school, and it is mostly used to train you on counting, so you can perform your addition, you can perform your subtraction. But the beautiful part about it is that it didn't just stop there, and something came up. Advancements begin to happen. What I mean by advancement is that people began to invent things. So it started from the first generation of computer, and at this point in time, computer was so big, that it could fill a room. It was so big, it was using what we call the vacuum tube. Okay, and then it moved up to the next generation, where we began to have the size of the computer reduced. Okay, and at this point in time, you can have it on a deck, on your decks. So we call it a desktop, where it uses transistor. Okay, then something happened again, an invention occurred, and the computer became smaller. Okay, and then it was using the integrated circuits, and afterwards it became smaller with the invention of your laptop. So at the fourth generation, where it was using it started using your microprocessor, the computer became smaller. Then that is where we started having your laptop, you started having your iPad, you started having your phones. Okay, but when it comes to technology, it won't just stop there. Something happened. There was a new invention, and now it's in the artificial intelligence. Now this is where we began to program robots to do things for us. Things became much easier, and that is where you talk about robotics. Okay, you program your your robots to perform some things, some tasks for you, and you just feel relaxed, and you allow the computer or the robot to do the job. Okay, so I believe you enjoyed this part. Now let's go to the program for today. So now let's talk about coding. Being that for everything we want to do, as kids, for everything you want to tell your computer to do for you, you have to send in a code. So now code is the language the computer understands. But you don't just code the computer without understanding what coding is all about. So the first question is, what is coding? And I read, computer coding is the use of computer programming language to give computers and machines a set of instruction on what actions to perform. So if you want your computer to go from the living room to your room, you just have to tell it what to do and how it should do it by programming it, by sending your codes into the computer. So the next part of coding says it is how humans communicate with machines. So You can't just speak to your computer. Yes, even if artificial intelligence have helped us in such a way that when you talk, your computer will understand. However, it can only understand if you have programmed your computer to act in such a way that it will recognize your voice. But aside just coding as a subject, what's the benefits of why should we code? Why should we code? Now, many of you have apps on your phone. You have your ways. We have our applications on phone. We have seen websites anytime we go on the internet, and you see each of these applications act in some ways different from other types of application. So if the programmer or the person coding this computer does not understand coding or programming, as the words can be used interchangeably, you find out that there will be nothing like software. So let's talk about something you're familiar with. Let's talk about your okay, let's make it an interactive section. Can you give me some apps you have on your phone that you like working with, maybe from on your dad's phone, on your mom's phone, maybe game or a study material? Can you just name it?
YouTube app.
YouTube app. Okay, so can you tell me what you use YouTube app to do?
Instagram.
Okay. Someone else.
YouTube app is used for WhatsApp.
Okay, what? WhatsApp. Okay, let's take it one at a time, so it won't be noisy. Okay, can I have the first person?
YouTube is used to watch some things on internet.
Good. YouTube is used to watch some things on the internet. Okay, next person.
You use Instagram for pictures and videos.
Okay. Good. Okay. So let's get back to class. So kindly mute your mic. So I can see that you're familiar with apps when or softwares or websites when I'm talking about it. So now, why do we code? We use it to make computer software. So just know that whatsoever you're doing, your program is done with code. So that is why we code. You want to invent something, you want to create something, so we code. Now secondly, it says that we use it is because we use programs every day. That is why we must code, so that we can create more program that will be useful to humans and will be useful for everyone. Okay, then the next thing says here, we use it to instruct we use codes to instruct computers and machines on what actions to perform. Earlier I was explaining something about your program working in different ways. Okay, so it's based on what you want to achieve. That is why you code. Sorry, let me accept. Okay.
But sir, what if the children don't code well?
Come again.
Sir, what if the children don't code well?
What if they don't code well?
Yes.
Okay. There's something we usually say. I would say it's an adage that says practice make perfect. You just have to keep practicing, and that is why you need a very good instructor that can take your questions and attend to. Sorry, somebody's mic is on. Just mute it. Thank you. Okay. So if you have issues with your code, you just need an instructor that can put you through. Okay, that can put you through and explain that can explain to you and give you the proper codes to use that will make your program work well. But guess what? If you can program once, definitely you can try to program another application better. All that matters is for you to keep practicing and try to think smart. So you think smart and practice. Don't worry. At the end of the class, we'll practice something together. Is actually an initiative that came to mind. So we're going to do it together. We're going to do it together. Okay. So let's move on with our class. And why we code, we use it to communicate with the computers. Let's move on, please. So what are the benefits to coding? What benefit do we get from coding? So first thing that comes here is that it makes us creative. I personalize it here. It makes me creative. So you as well can personalize it by telling yourself it will make me creative. So when you don't code well, just try to think smart, okay? Because the essence of learning coding opens your mind to new ideas. So it makes you creative. Sorry, come again.
Also in mathematics.
Yes, it makes you good with mathematics because and funny enough, almost all the okay, I'll give you this will be your assignment. Go and check through all the great programmers we have. You'll find out that they're very good with. Okay, hold on. Just try to this will be your assignment. I want you all to go and make a research about programmers and mathematics. You find out that all great programmers are good mathematicians because okay, if you'll find out that they are all great mathematicians because coding on its own opens your mind when it comes to complex or difficult things. So you find out that some people say mathematics is very difficult, but you find out that the logic you use in mathematics is the same logic you apply or you use rather when you are coding. So the benefit is that when your mind opens up to creativity, critical thinking, creative thinking, you find out that it boosts your knowledge in understanding mathematics better. So the next benefit here says that it makes you smart and intelligent. Have you ever wondered whenever you use a particular application, you keep wondering, have you ever wondered how did the creator create such a wonderful application? Let's talk about the games you have on your iPad, the games you play on your computer, or your video games. You find out that let's talk about the football. Let's talk about the Candy Crush. Let's talk about the sorry.
Subway Survive.
Yes, good. So you find out that have you ever wondered why is it looking so unique? Why is it so unique? And you find that each time you play the game, you want to come back again. You want to play it over and over again. That is because that is the benefit of coding. It makes you smart and what intelligent. And every intelligent person always do great things. You find out that in your schools, you find out that anytime you're smart, you're doing well, you'll be given a tag, right?
Every intelligent person always receive an award.
Yes, that's the reward for being intelligent. So this is the benefit of coding.
Using a phone or a computer, like a
Okay,
phone. Can you code the phone?
now let me explain something to you. That's a very good question, but at the same you asked the question about coding a phone. Now a phone is actually programmed with different kind of applications, programming language. And now, one thing you need to understand is that it wasn't the same person that programmed everything. That is where we come about collaborative task. So you work with with a group of people to invent a particular. So I just have to mute that person. To invent a particular software. So you find out that you have over 20 applications on your mobile. You find that it's not the same group of people that invented it, and it was used with different type of programming language. So what am I trying to say? We have so many programming language, or so many language you can use in coding. Okay, but let's not go there. As time progresses, we'll get there. Okay, so let's move on with our class. Because I would like us to also do practical, okay, before today runs out. Now, next is that the benefit, it makes me a good problem solver. Remember, for you to program anything, you actually want to solve a problem. You want to solve what? A problem. So as a programmer, or as a coder, the motive for you coding is that you want to solve a problem. Okay, and next says that it makes me confident. It makes you what? Confidence. Now let's quickly move on because of our time. So after coding, the next topic we need to understand is flowcharts. Flowcharts. For everything you want to do, you must understand flowcharts, and that is why flowchart is our next topic. So we are going to touch about two to three topics before we go into our practical section. So now let's discuss flowchart. What is flowchart? Flowchart is the graphical representation of steps. So the question will come
So what's the graphic?
Sorry?
A graphic.
Come again. What is a graphics, right?
Graphic.
Yes. Now, graphic is actually a picture. Let me use the word picture. So you find a picture on your wall. It's a form of graphics, but that is a visual art. So we have the digital art, like what you are seeing on my system via your phone is also a graphics. But you can see that I use images, shapes to make this image. So this is an example of graphics. Okay, so flowchart is the graphical representation of steps. Now the question is, okay, graphics and steps, how does it what brings them together? So I'm trying to tell you that for everything, for every program you want to develop, you have to have a picture, pictorial steps on how it should work. So let's look at this. This is a flowchart, example of a flowchart, and I would like us to watch a video on flowcharts before I explain this. So just stay tuned. Okay, I would like us to see this video before I explain this part of flowcharts. So just
Sir, can you code the TV?
can we code the what?
TV.
Okay, that's a good question. Okay, I didn't tell you I can code TV, but I know that I can do few things in your television. Okay, but not all. Okay. Okay, there's something I didn't tell you. Every programmer has the capacity, meaning that there are some things they can do, and that is why it's echoing. Okay, so just okay, just a second. Just a second. Okay, okay. So please just hold on. I'll share my screen now. So just listen attentively. I'm going to ask questions.
Welcome to 5 Minutes to Code, Programming Basics with your host Matthew C. Applegate. In this series, we are going to look at the fundamentals of computer programming. So whether you are hoping to program in Python, to code in C#, or to develop in Java, these short guides should help you get to grips with the basics to get started. You won't need to download or install any software, so just sit back and enjoy. In this series, we are going to be looking at sequence, selection, and iteration, as well as pseudocode and flowcharts. Today, we are going to look at flowcharts. So let's look at this in more detail. Flowcharts are often referred to as a graphical representation of a program. Why do people use flowcharts? Well, it has two very useful uses. Firstly, it can be used to help non-programmers understand what is happening in a program. The second use for flowcharts is for when programmers are trying to debug or solve a logic error in a computer program. As it is visual, it often helps programmers find where the program is going wrong a lot quicker. Let's look at some of the blocks that are available in flowcharts. Here we have the start and end block. These go at the start and the end of a program. These are comment blocks. This is a process block. There'll be plenty of these in your program. This is a decision block. This is an input-output block. Okay, here's an example program written in flowchart form. The syntax is written in pseudocode, which is similar to most high-level computer languages, but at the same time doesn't have the exact syntax. The first block, of course, is the start block. The second block is pretty straightforward. It is a comment. A comment is ignored by the program and is used for us humans to read. It helps us remember what something does, and if you're part of a team of programmers, it can help explain it to the other programmers. In the next block, the A variable is assigned the value of 10. This arrow means assignment. If you want to know more about this, check out the pseudocode video. It is similar to a single equal symbol. In this case, A equals 10. The same thing is happening with B below in the next block. However, B is being assigned 20. In the next block, we are totaling A and B together and assigning it to C, so C is now equal to 30. Following this, D is being assigned C divided by 2. This effectively halves 30 to 15, so D is now being assigned 15. Following this, we have an output block, printing D to the screen. An output block takes something from the computer and shares it with the real world. It outputs the value of D to the screen, which in this case is 15. And finally, we have the end block. So there you go. You can have comments, variables, and outputs in flowcharts. But that is just the beginning. In fact, most things can be achieved in flowcharts. Let's look at another short program. This simple program takes in 4 user inputs and adds it to the total at the end. At the top of our program, we have our start block, a comment block, and we assign 2 variables with the number 0 before commencing our for loop. The first thing it does inside the loop is to ask the user to type in an exam score. Next, we have an input block where we assign the user input to the variable number. Next up, we add the number to the existing total. Then we add 1 to the count, and at the end of the loop, we test if count is less than 4. If it is, we loop around. Once it has done this 4 times, it creates the average by taking the total and dividing it by 4 and assigning it to the variable average. Using an output block, we print the words the class average, and then in a second output block, we print the average as an output. So there you go. We have now added for loops and inputs to the mix as well.
I enjoyed that short video. Yes. I can hear you.
Sir, what is a comment?
Okay, a comment is just an information on your codes that just tell other programmers who check your codes what that particular code is all about. And now a comment is not executed by the computer. Can you hear me? I'm explaining your question.
We can't hear you.
Wow. Okay.
It is echoing again.
Okay, can you hear me now? Is it better?
Yes.
Okay. Okay, sorry about that. Okay. So somebody asked a question that what is a comment? That's a very good question. And that shows that you were following. Now, a comment is just an information on your codes that cannot be read by the machine. We call it a non-executable statement. So it only tells your computer, I mean, it only tells a programmer viewing your codes what that particular code is going to perform. For instance, let's assume, look at what we have on the screen. We have a flowchart, an example of a flowchart to add two numbers. Now I can place a comment that says this program will add two numbers and give you a result, or give you your results. Anybody that looks through my code will have it at the back of his mind that, okay, this set of code commands is meant to make this program calculate two numbers and give me a result. That is what comment is all about. So it's only an information, just like a tag that tells someone viewing your codes what your program will perform. So that's just a comment. Hope I was able to answer your question. Who asked the question? I think it was Sultan, and Sultan is not here. Okay, maybe it's network. Okay, someone else. Any question before we move on? We have less than 14 minutes for the practical section. Okay, if no question, let's move on. Thank you. So here is an example from the video that was you just watched. This is an example of a flowchart. So it's actually used, you can say we used shapes. That is why when the person asks what graphic is, somebody wants to say something. Okay, shift. Okay, let's move on. So you can see it's we used shapes, different shapes, to have a picture of a flowchart. That is why from the definition it says a graphical representation of steps. Now the steps tells us that when you start your program will do something, it will do something else, it will go else to the next step and perform the action there, go to the last step and perform its action there, then the program stops. So this particular flowchart is trying to calculate two numbers. So when your program starts, what happens? You input your first number, example your calculator. You want to calculate two numbers. You find out that you first need to press the on button, that is your start. After pressing your on button, you type in your first number, then you type in your operator if it's plus or minus. You type in your second numbers, then you press the equal to button, then you find that it gives you your result, and that's the end of that particular program. That is how it's meant to operate. So this is an example of your simple calculator. This is the flowchart of a simple calculator. So let's move on quickly. So benefits of flowcharts. Benefits of flowcharts. Sorry, please. Oh, are you following, please? Is that? Are you following, please? Charts. Let's quickly look through the benefits of flowcharts. Then we progress. Now, first benefit: it helps in understanding how to solve problems. How to solve problems. Okay, the problem of adding two numbers together. So through flowcharts, you understand how the program will work. Secondly, it says it shows us how to solve problems in picture or graphical form. So remember when I talked about our simple calculator, you find out that we add it on as a pictorial representation, which is using shapes and lines. So let's move on. Then the next says that it shows the flow of process in an orderly manner. So how is your program, how is it meant to work? Through the flow chart, it shows you that, okay, from the when you turn on your computer, you wait for it to load Windows. Then if you want to launch your game, you click on your game icon. Then when you click on the icon, the game launches. Then you begin to do other things. So that's an example of flowchart. Yes, move on. Go on, please. Go on, please.
Sir, in the YouTube app, if you want to join on YouTube or make a video on YouTube, how do you do it?
Okay, that's another class. Okay, we can talk about that if we have another class. Okay, now but to actually create videos on YouTube, it's very easy. You just need your video capturing equipment, like your video camera. You have to have a video editing software on your computer to edit your videos. Then you need to create a YouTube account. Once you have created a YouTube account, then you can upload your video to YouTube. So it's as simple as that. Okay, but how you go about it is it's not part of coding class. Okay, it's not part of coding class, but it's a good question. So let's move on, please. Let's move on, because we'll be having our practicals class in 9 minutes time. So these are the shapes you come across when you're talking about flowcharts. Okay, now when you want to draw a flowchart having your start and your end, we use the oval. Okay, you use the oval for your start and your end. If you watch the video, you find out that it's the same shape that was used. Then if you want to input anything from your keyboard, you want to input, or your program is meant to output, you're going to use the shape parallelogram. You use the shape parallelogram, okay, on your flowchart. Then for your program to add two numbers together, adding, we use the keyword sum. When you want to sum two numbers together, you use the rectangular shape. We use the word rectangular shape. Then the next is your flow lines. Okay, how should your program flow? Is it from up to down, or horizontally from left to right, or right to left? That is where you use your arrow key. The next shape here is your decision symbol. Your decision symbol is your rhombus. Some people call it kite, but it's your rhombus. Okay, or some people call it diamond. Your rhombus. So it's where you make a decision between yes or no. So that is the end of this section. Okay, I believe you have learned something. There's something else I would have loved us to discuss, which is algorithm. But because of our time, we will just have to proceed to the next section. Okay. So I want us to do something, because for this level we find that the best program that can work for you is a scratch program. Okay, so you're going to, everyone, if you have a scratch program, launch it up on your system. Let's do something simple, something unique. But before then, I'll just need to explain to you, for those that is just new in this program, because I know certain schools now include it into the curriculum or extracurriculum activities. So peradventure you don't have coding, you don't do coding in your school. Okay, this is an opportunity for you to have an idea of what this program is about. But okay, so please, I'll just share my screen from my hand. Hold on, please. Okay, so I will briefly explain the interface to you. Then after explaining, I'm going to tell you what we are going to create together. Okay, and I'll after explaining, I will need your suggestion on how can we develop a program to work, to meet up how can we achieve our task. Let me say it that way. How can we achieve this task? So first of all, this is the interface of Scratch, and this program is recommended for those in primary 1 and primary 2. And we have over 100 projects which can be done on this program. Okay, and some projects will require you downloading some materials, or let me use the word, some tools you can use in this program. But before then, let's just move on. Now, this is how the program works.